Okay, so this is a discussion of independent variables in the context of the data analysis control assessment task. And an independent variable is the one that's deliberately changed by the person doing the experiment. So you'll be given a hypothesis for your control assessment, and you will have to change one of the quantities in the hypothesis, and it's the one that you can deliberately change. So in these three examples then, we're going to identify what the independent variable is. In the first one, a student is testing to see how changing the angle of a slope affects the time it takes for a car to roll down the slope. Well, clearly the student can't directly affect the time it takes for the car to roll down. The only thing they can change and control directly is the angle of the slope. Common mistake here is to not put the whole thing in, so people will sometimes write down angle instead of angle of slope. Right? It is important to put that second part in because the angle could refer to anything. Right? You have to be specific. Number two, phrased slightly differently, a student is testing to see if the time it takes for an ice cube to melt is affected by the temperature. Well, again, the only thing they can actually sort of change deliberately is the temperature. They can't deliberately make the ice cube melt in exactly 30 seconds because that depends on the temperature. So the independent variable here is the temperature. Now, both examples 1 and 2 contain the word affects or affected, and here's an example of an experiment described without using that word, so you've got to be a little bit more on the ball. Okay, a student is doing an experiment to test the relationship between the concentration of a solution and the rate of a chemical reaction. Well, again, you've got to think about what you can actually change yourself, and in this case it's the concentration of solution. That's what you can decide. You can decide to have a 0.5 molar solution, a 1 molar solution, all right? And that's what you are able to change. So that's the independent variable. A common mistake here is to put the unit instead of the quantity. So, for example, some students will say that degrees is the independent variable for example 1 up here, where it's angle of the slope. Right? We've got to be clear. The degrees is the unit for angle. Right? It is not the variable itself. So it's incorrect to say that degrees is the independent variable for example 1. You must make sure you're talking about the quantity and not the unit. Okay, so pause the video and have a look at these examples. Try to identify the independent variable in these ones, and we'll go through them in a sec. Okay, so number 1, a student changes the length of time she is exercising and measures her heart rate afterwards. Well, hopefully the whole of that length of time she is exercising. Hopefully you didn't just say length of time, right? It is the length of time she is exercising. Because length of time on its own could have been length of time that she stopped after exercising before measuring her heart rate. This is why it's really important to be specific. Those two things will have vastly different effects. Number 2, a student wants to know what the effect on the force between two magnets will be if he changes the distance between the magnets. Well, there's a massive clue in here because it says if he changes, right? And again, it's distance between the magnets, not just distance. Because that could be anything. That could be the distance they both are from the edge of the desk that he's got them sat on. It could be anything. So distance between the magnets is the full thing. And finally, a student is trying to find out what the relationship is between the distance of a solar-powered car can travel and its charging time under a lamp. And this example comes from, if you've looked at it, the discussion about outliers. And again, there's no word affect here or nothing about changing one thing. It's all talking about the relationship. You've got to think about what's going on, okay? The only thing you can choose to change in this is the charging time under the lamp, okay? We can't directly affect the distance, right? We can't decide it's going to travel 1.5 meters. We decide to put it under the lamp for a certain amount of time, and then we measure how far it travels as a consequence. So that's the discussion on independent variable.